All right, in this video we're going to be finding the inverse of some logarithmic functions. So we're going to start with this expression we see here, y is equal to the log base 4 of x. Now when I find the inverse, the first step is always to switch x and y. So that's what I'm going to do right away. I will switch x and y and rewrite this as x times the log base 4 of y. Now the next step in finding an inverse is to work to solve for y. So that means I need to get y by itself. There's a couple of ways to think about this. If I want to get y by itself, one thing that I could do is I could simply rewrite the expression in exponential form. So in exponential form, this logarithmic expression would be, thinking about what this logarithm means, this means that if I take 4, this base, and raise it to x, I get y. If I want to get y all by itself, that'd be probably a pretty good thing to do. So based on the definition of logarithms, if I just rewrite it in the other format, the exponential form, I would have 4 raised to the x power is equal to y. Y is all by itself, there would be my inverse. So I've got y equals 4 to the x is the inverse of the log base 4 of x. Well, there's another way that I could have you think about this. We'll come back in a second. We're going to do this next example here. So to find the inverse of the natural log, or the ln of x plus 2, I would use the same process. I would switch x and y. X is equal to the ln of y plus 2. You might be tempted to subtract the 2, but it's inside a parentheses, so we need to take care of the logarithm part of this first. Now when I have ln, the natural logarithm, that means I have a base of e, the natural number. So what I'm going to do is I'm going to just put a little e there to remind myself. Now, at this point, to undo the logarithm, I'm going to rewrite this expression in exponential form, which means take this base, e, raised to this power, x, and that will equal whatever this expression happens to be, in this case, y plus 2. Now, the last step here is to get y all by itself. So there's that plus 2 tacked on at the end. Well, we can take care of that if we subtract it from both sides. Now, e to the x is a power, minus 2 would be written down on the main level. That would be equal to y. So there would be the inverse, y is now all by itself. There's the inverse of the logarithmic expression that we started with. And so there's another way to think about this. To do it this way, you just have to understand how logarithms work and rewrite it from one format to another, which works for some people. The other way is to think about this algebraically. Now to do that, I'm going to remind you of some steps that we took before. So if I trust that y equals b to the x power and y equals the log base b of x are inverse functions. One undoes the other. That means when I compose them, which we did in an earlier video, when I take the f of g of x, plugging one to the other. So I'll label this as f of x and g of x. When I compose these two inverse functions, I am supposed to get the identity function x. Okay, remember that. So when I take b raised to the, replace x with the other function, the log base b of x, I get x because they're inverse functions and the definition of inverse functions tells me so. So that equals just x. And when I go the other way, I'm going to take the g of f of x and compose them. Well, that'd be g, which is the log base b of something. I replace x with the other function, b to the x power. This expression is also equal to x, the identity function. So, that being the case, if I wanted to find the inverse, let's say, of the one that we just did, which is y equals log base 4 of x, I would switch x and y, and then solve for y. So check out how I would solve for y. I'm going to use an inverse operation. When I say inverse operation, I'm relating that back to if I had 3x equals 9, the way that you would solve that equation is you would divide by 3. Because division by 3 is the inverse operation of multiplying by 3. I think you're all comfortable with that idea. Well, I'm going to use an inverse operation here. If I have a logarithm, the inverse operation would be an exponential function. Whoops, didn't do that. It'd be an exponential function. So what I'm going to do is I'm going to turn this into an exponential function by exponentiating both sides. Here's what I mean. Looking at this expression here, I've got a base raised to the log base b, the same base, of x is equal to x. I'm going to make that same expression happen here. I'm going to take 4 and make it the base of a power with the log base 4 of y as the exponent. Now, by the definition of inverse functions from above, the 4 to the log base 4 kind of cancels and leaves me with just this expression, y. Algebraically, if I perform an operation on one side, I need to do the same thing on the other, so I'm also going to take 4 and raise it to the x power, whatever happens to be over here. So when I'm done, y is equal to 4 to the x power. And if you remember, that's the same thing we got when we found the inverse by just simply flipping the expression from one format to the other. So it just depends on your way of thinking. Do you like to do algebraic steps and think of it as an inverse? Great, do that. Right? Now, if I wanted to go the other direction, let's say I had y equals 4 to the x power, and I wanted to find the inverse. I would switch x and y, and then I would solve for y. Again, using these inverse operations here, if I have an exponential function, the inverse would be a logarithm. So here I have the log base b of b to the x power is equal to x. I'm going to use that same idea right here. I'm going to take a logarithm with a base of 4 of 4 to the y power. And based on my definition of logarithms and inverse functions, that should equal just y. Now, if I perform an operation on one side, I need to do the same to the other. So I take the log base of 4 of x, and I end up with the log base 4 of x is equal to y. There's my inverse. These two things being inverse, that's the same as I did over here. Log base 4 of x and 4 to the x power are the inverses of each other as well. So just a couple of different ways to think about finding the inverse of a logarithmic or an exponential function.